With incredible speed and efficiency, Llama 3.3 is pushing the boundaries of AI. It delivers an almost magical level of AI performance. But here's the big question. Are we ready for such speed and power? Is it a revolution or just a flash of hype? In this video, we'll explore Llama 3.3, compare it to previous versions, and analyze its benefits against ChatGPT. So Meta just unleashed Llama 3.3, and get this, it uses only about 1/7 the parameters of their previous 405 billion parameter Colossus. With just 70 billion parameters, it still achieves almost the same performance. That efficiency means lower costs, smaller GPU demands, and the power to turbocharge everything from everyday AI tools to immersive VR worlds. Llama 3.3 is Meta's new multilingual large language model, boasting 70 billion parameters. While that might sound huge, what's really impressive is that it performs close to Meta's previous giant, Llama 3.1, which had 405 billion parameters. Llama 3.3 delivers near top-tier performance with far greater efficiency, like a sports car that's nearly as fast as the ultra-expensive model but consumes way less fuel and space. Mark Zuckerberg announced that Llama is now the most adopted AI model in the world, with over 650 million downloads. This massive uptake highlights how many developers are building on these open-source AI protocols. Open source is key here. Meta aims to be the backbone for numerous AI projects. Though it seems like they're giving it away, if everyone builds on Meta's foundation, the company could gain significant market influence over time. Meta is also expanding its VR efforts, working to make their VR tools industry standards. If they control leading AI and VR tools, they're essentially shaping the future of digital connectivity and perhaps even the metaverse. They're teaming up with third parties to grow this influence. The more people rely on Meta's tools, whether for AI or VR, the more Meta becomes the central player in the future of digital interaction. On the practical side, Zuckerberg also mentioned a new AI data center in Louisiana and an undersea cabling project to support Meta AI's growing needs. Meta AI reportedly has around 600 million monthly active users. However, with over 3 billion users across apps like Facebook, Instagram, Messenger, and WhatsApp, they've embedded AI assistants into all these platforms. They're also nudging users toward AI-powered features like image generation. However, the question remains, what's the compelling reason for everyday users to embrace AI assistants in social apps? For now, the adoption might feel more like a push than organic demand. Still, the true value could emerge as VR and other advanced technologies become more mainstream. From a technical perspective, Llama 3.3 is open source and multilingual, supporting languages like English, German, French, Italian, Portuguese, Hindi, Spanish, and Thai. Llama 3.3 was trained on massive 15 trillion tokens of data sourced from publicly available resources. This extensive dataset includes a diverse range of text types, enabling the model to better understand and generate human-like text across different contexts. Additionally, the fine-tuning data consists of publicly available instruction datasets, along with over 25 million synthetically generated examples, allowing Llama 3.3 to handle a wide variety of tasks with enhanced accuracy and versatility. This vast training data also enhances performance across tasks like reasoning, coding, STEM problem solving, and trivia. Enjoying the video so far? Don't forget to like if you're excited about the future of AI with Meta's Llama 3.3. Share this video with someone who's interested in AI advancements, and let us know in the comments what features you're most excited to see. We love hearing your thoughts. Llama 3.3 also supports ultra-long context windows, 128,000 tokens, roughly the length of a decent-sized book. This allows the model to handle lengthy documents and maintain coherence over many pages. Additionally, Meta introduced Grouped Query Attention, or GQA, which boosts memory efficiency and speeds up inference, the process of generating answers or predictions when using the model. Cost efficiency is another game changer. Llama 3.3 generates text at just 1 cent per million tokens, significantly cheaper than competitors like ChatGPT-4 or Claude 3.5. It also slashes hardware requirements. While the older 405 billion model needed nearly 2 terabytes of GPU memory, Llama 3.3 can run with tens of gigabytes, reducing GPU costs dramatically. For developers, Llama 3.3 is mostly free and open source under a community license agreement. However, organizations with over 700 million monthly active users need a commercial license from Meta. Users must also credit Meta and follow an acceptable use policy to prevent harmful content generation or unlawful activities. Safety and trust are priorities for Llama 3.3. Meta employed techniques like supervised fine-tuning, or SFT, and reinforcement learning with human feedback, or RLHF, to align the model with safety standards. Safeguards like Llama Guard 3 and Prompt Guard prevent harmful outputs. Meta also conducted extensive red teaming to identify and address vulnerabilities, ensuring the model's robustness. Environmental considerations were also factored in. Training Llama 3.3 required 39.3 million GPU hours, resulting in 11,390 tons of CO2 emissions. However, Meta claims they achieved net zero emissions by using renewable energy and have publicly shared these metrics for transparency. Performance-wise, Llama 3.3 excels across benchmarks, often surpassing similarly sized models. It achieves 86% accuracy on MMU, or knowledge across subjects, 77% on math benchmarks, and impressive scores on coding tasks. While it doesn't outpace ChatGPT-4 in every test, it comes remarkably close. Developers can access Llama 3.3 through Meta's site, Hugging Face, GitHub, or other platforms. It integrates seamlessly with tools like LangChain and TorchTune, and it's cloud-friendly on AWS, GCP, and Azure. Its flexibility makes it suitable for diverse applications, from natural language understanding to specialized fine-tuning for custom tasks. For those of you who might be new to the Llama family, let's briefly go over what it is. Llama, short for Large Language Model Meta AI, is a series of language models developed by Meta. Llama models are built with the goal of pushing the boundaries of AI and providing researchers with powerful tools for a wide range of NLP tasks, from text generation and understanding to question answering and more. Llama 3.3, the latest release in this line, comes with some significant advancements that are worth exploring. But to really appreciate what it brings to the table, we need to take a look at its predecessors and see how the evolution has shaped this new version. The key differences between Llama 3.3 and previous versions. Number 1. Model architecture and scaling. Llama 3.3 introduces advanced optimization techniques, balancing model size and performance. Unlike Llama 2, it achieves greater efficiency without significantly increasing parameters, allowing better performance with fewer resources. Number 2. Performance improvements. Llama 3.3 improves on Llama 2 with enhanced accuracy and fluency, especially for complex queries. It performs better on nuanced NLP tasks and adapts well to diverse, unpredictable tasks, making it more reliable for real-world applications. Number 3. Training data and methods. Llama 3.3 utilizes a broader spectrum of data, including real-time sources, allowing it to adapt to evolving trends. The model's improved filtering methods reduce bias, enhancing accuracy and context relevance. Number 4. Fine-tuning capabilities. Fine-tuning is a crucial part of large language models, allowing them to be adapted for specific tasks or domains. Llama 3.3 introduces significant enhancements in fine-tuning capabilities. Meta has rolled out more effective methods for customizing the model to specific use cases, simplifying the process for researchers and developers to modify the model's behavior according to their unique requirements. While Llama 2 offered solid fine-tuning options, Llama 3.3 advances this with the addition of finer control over model behavior. This enhancement allows for more accurate modifications, which can result in improved outcomes for specialized applications, whether in legal, medical, or technical areas. Number 5. Efficiency and cost effectiveness. One of the persistent challenges with large language models is their resource consumption. Llama 3.3 significantly improves on the efficiency front, offering faster processing speeds with lower resource requirements. Meta's implemented optimization strategies that allow Llama 3.3 to deliver high performance while using less computational power. This is especially crucial for increasing the accessibility of Llama 3.3 to a wider audience of developers, researchers, and businesses. Whereas Llama 2 demanded significant infrastructure to operate successfully, Llama 3.3 lowers the entry barriers, allowing more individuals to benefit from advanced AI technology without the requirement of high-end hardware. Number 6. Ethical considerations and bias mitigation. Llama 3.3 has stronger mechanisms for detecting and mitigating bias, ensuring more balanced, fair, and inclusive responses, addressing ethical concerns more effectively than Llama 2. And number 7. Applications and use cases. Although both Llama 2 and Llama 3.3 offer great versatility, Llama 3.3 stands out for its wider array of possible uses. Due to its enhanced performance and efficiency, Llama 3.3 is more appropriate for real-time applications such as live chat systems, automated content creation, and interactive AI-driven tools. Previous versions, while capable, were often limited to more specific use cases or required extensive customization to fit particular tasks. Llama 3.3, with its enhanced fine-tuning and adaptability, opens the door to a broader set of possibilities, including integration into business operations, customer support automation, and creative content generation. To sum up, Llama 3.3 represents a significant advancement in artificial intelligence, offering impressive performance as compared to ChatGPT, making it a killer of GPT-4, cost-effectiveness, and adaptability, while also prioritizing safety and sustainability. Meta's goal of merging AI with VR tools paves the way for a future where these technologies serve as the foundation of digital connectivity. Thanks for watching, and don't forget to like, comment, and subscribe for more updates on the latest in AI and technology. See you in the next video!